Hello, my name is Mark Fink from Breault Research Organization. The topic of my presentation today is heat-resistant visual landing aids, supported under NAVAIR SBIR topic N102-132. It is a form-fit function, energy-efficient, solid-state light, a direct replacement to the tramline, centerline light fixtures. Breault wants to be your optical engineering partner. Our core capabilities cross multiple disciplines and center around system solutions. Some of our core capabilities include stray light analysis, illumination systems, optical system engineering, prototyping and high-end production, and commercial software. The picture on the lower left is a luminous intensity meter, incorporating a processor, photopic detector, and laser rangefinder. It measures range, illuminance, intensity, luminance in both English and metric units. This commercial product was recently released and will be posted on our website with information on pricing and availability. The picture in the middle is a simultaneous view correlation radiometer, also known as a gas filter correlation radiometer. This air-mounted commercial product is used to detect natural gas leaks, but can be modified for any other gases as well. It will be posted on our website soon with information on pricing and availability. The picture on the lower right is ASAP, Advanced System Analysis Program, one of our commercial software products. It is a non-sequential ray tracing program able to model light's interaction with physical hardware. It can model sources, multiple wavelength sources, physical optics, imaging and non-imaging systems, diffraction, and much more. Our SBIR directly addresses a Navy need: reliable visual acuity, which means increased crew and equipment safety. We do this with a new in-deck lighting fixture. It is more durable compared to the legacy system. With the introduction of the vertical takeoff and landing F-35, very hot aircraft exhaust is directed at the deck. Our light fixture is resistant to those extreme aircraft exhaust temperatures. Furthermore, our new deck fixture will survive exposure to the elements: humidity, high temperature, low temperature, and other fuel and fluid contaminants. Our new deck fixture fits and supports constrained Navy budgets. More durable also means longer life cycle, which reduces maintenance cost. We have also eliminated galvanic corrosion, which is a significant problem with the legacy systems. We also address the government directive for energy efficiency. We have reduced electrical consumption by over 90% with the introduction of LED lighting. Deck lighting in use today is the tramline and centerline light systems. It starts with a remote source located below deck in a light box. Light from a 150-watt MR16 bulb is coupled into a 48-inch long fiber optic bundle. Light exits the fiber bundle into a converter assembly, where a mirror and lens redirect and couple the light out of the deck fixture through a small aperture. A rectangular beam pattern is formed, roughly from 0 to 10 degrees vertically and plus or minus 25 degrees horizontally. The amphibious ship tramline systems has an NVG filter attached to the end of the fiber optic bundle, while the centerline system for the carriers does not have an NVG filter. There are several desired specifications the new in-deck fixture must meet. First, it must be resistant to and continue to operate when exposed to high-temperature aircraft exhaust. And there are two situations. One, indirect exposure or side blow for long dwell time, and the second is near direct or direct exposure for short times. It must have low or less maintenance cost and low power consumption. If we're using the legacy system, it needs to prevent moisture from ingressing into the optics assembly and fiber optic bundle. It also needs long life light sources with low life cycle costs and prevent formation of galvanic corrosion. Breault's lighting solution easily fits into existing tramline and centerline fixtures. It is a form-fit functional replacement, as seen in the picture on the right, which shows the system developed during Phase 2, mounted in an optics deflector. It uses two low-power LEDs. Custom optics and LED current driver are packaged in a sealed new converter assembly. The housing uses 4130 steel for robustness in harsh environments. 4130 steel is similar to the deck material, thus preventing galvanic corrosion formation. The new system increases operational capability and mission readiness. Our schedule is based on success. We are completing design improvements to correct issues found during Phase 2 validation testing. Once completed, we will have a design review in June to verify we meet requirements. Then, we will assemble and functionally test prototype units. We will validate luminous intensity and do in-house leak testing. We will also conduct environmental and EMI testing to validate that we meet those requirements. Next, we will ship several units to the Navy for evaluation, testing, and qualification. First, photometric testing will be done to validate brightness and night vision goggle compatibility. Then, shipboard testing will be done to validate the new light fixture functions with ship controls. Breault is a can-do company and plans to take an active role from development, testing, and qualification as the light fixture transitions into the fleet. We plan to provide tramline and centerline light fixtures to the Navy and will complete all necessary supporting administrative and programmatic documentation. We will expand our focus and look for opportunities to transition the technology to commercial markets, such as airports and airfields. From our development and manufacturing experience, we will look for opportunities to provide maintenance services on illumination systems. And finally, we will continue to develop solid-state lighting products for other applications. Breault looks forward to working with or supporting other organizations that may benefit from this technology or Breault's engineering services. Program Office PMA 251, Aircraft Launch and Recovery, a sponsor of this SBIR, is responsible for the lighting systems on all air-capable ships. We can support them and address design and performance illumination issues to include obsolescence, which is a significant problem with many legacy systems. We can support O-level shipboard maintenance organizations with our expertise evaluating and repairing illumination systems. More generally, Breault can also support NAVAIR field service support units to address system issues. Finally, we look forward to working with and supporting the primes as Breault supplies light fixtures or other illumination systems during new ship construction. That concludes my presentation for today, Heat-Resistant Visual Landing Aids. Thank you for listening in on this virtual presentation. My name is Mark Fink, and I am at booth N102-132. Please stop by to discuss this technology or your NVG, illumination, lighting, optical, or system engineering needs. I look forward to talking with you soon. Goodbye.